I really like developing software under NetMF, but execution speed can be a drawback. I mean, usually it is fast enough for many embedded applications, but sometimes not. So the idea originated from Micromint USA with the Bambino, a dual-core MCU.
Here I made my own module with the bare minimum, just a freescale Vibrid and a memory map flash. I ported NetMF to Cortex-A5 and the Cortex-M4 runs MQX RTOS. Actually, this was my very first BGA experience, and the first reflow didn't work out too well because the oven fan pushed the chip during cooling sequence. So on the second trial, I disconnected the fan and manually opened and closed the door, the oven door, whenever the fan LED was being turned on or off, and it worked great. To use the module, I need to hook a JTAG probe. I will use Crossworks for native code, and Visual Studio will deploy with a USB like this, and that's it, ready to rock and roll.
But first, let's see how the two cores communicate with each other. Basically, the master wants the slave to execute native functions, and the master also wants to be informed by the slave of particular events. To invoke a function from managed code, we can pass any number of input parameters. Code is blocking, only for the coding thread, of course. I also wrote a tool to completely generate the glue between manage and native. Here's the syntax, and my class is tool generated. And this is a demo I'm going to run. The A5 runs TinyCLR directly from Flash. The main function creates a thread to blink the LED and passes a bunch of parameters to M4 native function, which will just display them before returning a hello world to managed code. In managed code, we create the LED blink thread and pass a bunch of parameters to M4 native function. Function slave is entirely tool generated, so we don't have to worry about it. On the native side, dispatcher is also completely tool generated, and we just need to implement function slave. Here we display the parameters and return a hello world. But before I inserted a breakpoint. So let's run this guy. MQX, now it's running. We run managed code as well. Okay, the LED is blinking. On F5, this thread we're waiting for the result from M4. Waiting because we got a breakpoint. And on native, we display the parameters and stopped on before returning hello world. So now something very handy. I will make a change to native code. and restart it. Here M4 detected that previously function save was not completed, so it gets re-executed again. We are still waiting on the A5, so let's carry on. And here we got our Hello World one. This is really neat because it's possible to debug and change native code without having to restart A5 in between. Many thanks to Michael at Crossworks for integrating the reset setting, because now it's completely transparent. Regarding events, the master first provides a number to the slave, and on a given condition, the slave generates an interrupt with that number. Here is syntax, typical NetMF stuff, similar to interrupt port. And here is a demo. The ID is first passed to the M4, which here is running the MQX mouse demo. M4 runs the USB host stack, and on each mouse click, it sends an interrupt slave to the A5. Talking about USB, I wanted to add a USB driver to TinyCLR, so I first isolated the USB CDC driver from the MQX VirtualCom demo and ported it to TinyCLR. Now, the nice thing about it is that this job took a bit over a week to complete, with no prior experience with USB drivers, and without taking a look at either the USB protocol specifications or the Vibrid reference manual USB chapter. It was pretty nice to be able to reuse the MQX drivers, because a lot of work has already been done there by the folks at Freescale. In manage code, we pass the interrupt slave ID to the M4 and then just wait for interrupts. The native side, I added a couple of interrupt slave on mouse clicks left and right. This program is the MQX mouse demo, which is part of the MQX distribution package. Let's run native. Then managed. Okay, so left click, right click, left click, right click, right click. Okay. To all those outstanding people who contributed directly or indirectly, thank you. And thank you for watching.